Hello everybody and welcome back to question number 4 on the 2016 MMC or Manitoba Math Competition. Okay, so we just took a look at question 3, now we're on to question 4. We're getting our way through this contest. And let's see what question 4 has to offer. It's another two-part question, as the first few tend to be on these contests. And it won't be the last one. Question 5 is a two-parter as well. So, question 4A. The sum of two numbers is 10, and their product is 20. What is the sum of their cubes? Alright, so I don't know what these numbers are, but I'm going to give them names. So we might say something like, let A and B be the two numbers. What are we told? Well, we're told what A plus B is. We're told that that's 10. And we're told the product A times B is 20. Fantastic. How can we get, what do we want? The sum of their cubes, right? What is the sum of their cubes? So we got A cubed plus B cubed. Now, with the two pieces of information we're given, we can probably solve for A in terms of B and things like that. You'll get if you sort of rearrange and say, A is 20 over B, and plug that back into the first equation and then multiply through by B, you will get a quadratic in B. You'll get two solutions for B. One of them will be B, the other one will be your A, and so you'll still get A and B as a pair being the same two numbers. It's just, is this one called A or is this one called B? And that's a great way to do it. And I imagine a lot of people did it, but there's actually a niftier, faster way to do this sort of question, rather than solving for potential A's and B's and then cubing them, because I imagine it's not going to be nice to cube whatever A and B we get out. But this is another example of questions where you don't actually have to solve for A and B to work them out. So, so we want A cubed and B cubed. Can we think of an expression involving either A plus B or A times B that has cubes in it? Well, if we take A plus B cubed, that would be A cubed plus 3A squared B plus 3AB squared plus B cubed. It has the A cubed plus B cubed that we want in it. And we know what A plus B is. It's 10. So 10 cubed. Well, 1,000. That's great. But we have this extra bit. Okay, we want to get rid of these extra things sitting out here. 3A squared B and 3AB squared. Because then we'll just be left with A cubed, B cubed. Alright, but these have squares in them. What are we to do? Well, first we can take out a factor of 3. We can also take out a factor of AB, and we'll be left with A plus B. So we do indeed get A cubed plus B cubed here. Okay, great. So that means A cubed plus B cubed, the sum of the cubes, is 10 cubed minus 3 times 10 times 20. So that's 1,000 minus 3 times 20 is 60 minus 10 is 600. So the sum of the cubes, whatever they are, is 400. So you'll notice I have no idea what A is. I have no idea what B is. I don't need to know. Okay? We could do quadratic formula. We can get an A. We can get a B. That would work just fine. But then we're going to have to cube them. And unless A and B turn out to be integers, cubing them and adding those two results is going to be a bit of a pain. Okay? And you can already sort of see you're not going to get nice integers here, because you would need something like 4 times 5 to get you 20, but 4 plus 5 is 10, so that's a little short. And then, okay, well, how can we get 20 there? Well, we could do, 3 times 7 is 21, but the 3 plus 7 is a 10. You're not going to get there with integers, and so cubing and then adding is going to be a bit of a hassle. But if we're clever about it, we can set it up where it doesn't matter what A and B are at all. We get 400. Okay. So that was A part. We got a B part here. Can one make the expression 1 star, 2 star, 3 star, so we sort of have a star operator? Can one make this expression all the way up to 10 equal to 0 by replacing each instance of star with either plus or minus? Okay, so star is sort of standing in for a plus or minus, and we get to choose at each stage what we've got. So can we do that? Can we make it equal to 0 by replacing them with pluses and minuses? So we could experiment around, and we could, take the 1, 2, 3, 4, all the way up to 10. And we could start putting, pluses here and minuses here, and oh, how much have I added so far? Okay, I should take off a little bit, so we'll do -7, and then oh, we've gone too far, so we'll add on 8, and that sort of stuff. So you can play around with it like that. But if we're asked, can one make the expression? So we're going to have either yes, and we have to work out, that this star here is the minus, and this star here is a plus, and these couple are minuses. So we'd have to work out an expression and say, yep, here's an expression that does it. Or we're going to have to be able to say, no, you'll never be able to do it. And here's why. Here's our proof. Okay. Now I'm tending to think that it'll probably be a proof just because they like explanation, and it's kind of hard to explain why you do this minus and this plus and so forth. You sort of just have to say, it's 1 minus 2 minus 3 plus 4 plus 5 minus 6 plus 7, blah, 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 equals 0. There it is. That's all the justification you can give. Now, if we're going to try and prove that you can't, and again, there's not really an indication other than the way contests tend to be run, there's not really an indication that we can't do this. We're going to have to sort of develop a general theory, because we can't try there's going to be 9 stars, so we can't try all the 2 to the 9 possible combinations. That's 512, that's way too long for this competition. We're going to need to sort of develop a general theory, and when it comes to doing that, I tend to start small. So instead of going up to 10, what if we just had 1 star 2? Can I make this a plus or a minus and get myself a 0? No, I'll either get 3 or -1. So that's not looking so good. How about 1 star, 2 star, 3? Well, it's not terribly difficult to see. If you do 1 plus 2 minus 3, you get 0. So you can do it with 3, you can't seem to do it with 2. Alright, well, let's keep going. 1 star, 2 star, 3 star, 4. Now, I can do 1 plus 2 and then subtract off 3, but then I got this 4 left over. That's not working. So is there no way to do that? Okay. So if I do 1 minus 2, that's -1. So if I add on 3, then I get 2, and I get minus... No, that's not going to work. What if if I get 1 minus 2 minus 3, so that's -4, then plus 4 equals 0. So I couldn't do it with 2, I can do it with 3, I can do it with 4. How about 5? So 1 star 2 star 3 star 4 star 5. Now this is getting to the point where it's a little ridiculous. There's going to be 16 different possible sums. I might get lucky and find a way to make it 0. But if this is a case where it's not going to happen, like over here, it's going to be very exhausting for me to work it out. So there's got to be a faster way to do this. So it worked for 3, it worked for 4, didn't work for 2. I'm not particularly noticing a pattern there. But I'll tell you what I do notice, and I'll highlight it a little bit. I notice that the 2 and the 3 are in here, they add up to 5, and the 1 and the 4 add up to 5. These guys add up to 3, and of course this guy adds up to 3. So let's just, I'm going to develop my theory. I'm going to jump to the 10 as is. So if I could do this, star 7, star 8, star 9, star 10. So if I could do this, I could rearrange, I could group the numbers that are subtracted and the numbers including 1, because 1 is always sort of there's always secretly a plus in front of him, including 1, that are added. And so I could get, 1 plus, and then minus a bunch of other numbers. Blank plus, blank plus. So the added numbers and the subtracted ones, I could group them like this. But if this is going to be equal to 0, then that means both of these have to add up to the same number. Both have to add up to s, some sum. And you do s minus s equals 0. So we need to be able to divide the numbers from 1 to 10. Into two groups that add to the same number. Okay, this is possible with 1, 2, and 3 because you just take 1 and 2 in one group and 3 in the other group. Or 2, 3 in one group and 1 and 4 in the other group if it's 4. Now this doesn't work for 2 because there's 1 and 2. Either they're both in the same group and that group adds to 3, or they're both in separate groups, which one group's going to add up to 1, one of the groups is going to add up to 2. So what would happen with 1, 2, 3, 4, 5? So we'd have one group, like 2, 3, and 5, and then we'd have another group, 1 and 4. And we'd need them to add up to the same amount. Well, I don't know who's going to go in each group. And again, there's sort of 16 possibilities. I can't work them all out. But one thing they have in common is the sum of all the numbers, so the sum of both groups, so this should be 2s, is going to be equal to 1 plus 2 plus 3 plus 4 plus 5, which is 15. So you can't have such an s. Such an s would be an integer, but it's also 15 over 2, and there's our problem. So the same sum s, which is an integer. But then 2s is 1 plus 2 plus 3 all the way up to 10. So this sum, there's lots of ways to calculate it. You can do 10 times 10 plus 1 all over 2. These are triangular numbers are formed by doing 1 plus 2 plus 3 all the way up to n. Or you can just add them all up. It's not that hard. You get 55. So s would be 55 over 2, not an integer. So this is what we call a contradiction. We know it has to be an integer, and yet the math says it isn't an integer. We've got a problem. So our original assumption that we could replace these in some way to get 0 is false. So no labeling of our stars, no changing of our star operations will give a sum of 0. We've shown that. If there were one, we'd have to be able to split the numbers like this so they add up to the same amount. Then if we added up all the numbers, it'd be twice that amount, but then that would be 55. We know this amount has to be an integer because it's a sum of integers. If you feel the need to, you can add that in. But then 55 over 2, not an integer. Well, there we go. Not a bad question. I like that. It's a good question. Good question 4. Hopefully question 5 will be just as good, but we'll handle that in the next video. Thanks for watching.